If you have a shower curtain like this, then it's probably fallen down and it is an absolute nightmare, especially if you are in the shower. So the problem arises because this section is not attached to the wall strong enough and it slips. So what you need is a little bracket, which I have designed using Onshape CAD and then 3D printed it, and I'll show you how to do this. So this is using Onshape to make this little bracket to support the rail for the shower curtain. And yeah, I was very pleased with this. It's actually very straightforward. I'll take you through it step by step. Obviously you need access to a 3D printer, which I fortunately do. And this has worked really well, so it solved the problem. So rather than draw it line by line, I'm going to take you through the menu on the left because it's pretty straightforward. So you're going to start off with a simple sketch. So just do, I did it on the front plane, so a rectangle. You can align it in the middle. You could make some measurements depending on your shower rail. I think they're all fairly standard. I did 70 mils horizontal, 30 mils height, and then you accept the sketch. And then you extrude that. I extruded that to 12 mils just to make a nice rectangle like that. That was fairly straightforward. And then on one of the faces here, so the near face, I did a line at the top. So that was going to be this thing up here, the midpoint line. And then drew a line down here, put some dimensions on. I did this as 15 mil radius and a 10 mil line down here. And then I used the sketch mirror, just to repeat that over here. And then I did a semicircle. I think I used a 3-point arc up here. And then that should all grey out. That should be closed contour. And you get this particular shape here on one side. And then I accepted that. And I flipped it round onto the other side, onto the back. Basically drew the same thing with slightly different dimensions. So midpoint line on the top, 11 mil radius, or 11 mil dimension, 10 mil line again, so I kept that the same, mirrored that onto the other side, and then again did a 3-point arc to join that up. So we have these two shapes on either side, and now I lofted the two together. I think normally when I'm doing lofts, I would do new, add, or surface. So this was, I think, the first time I've done a remove loft, and that's quite straightforward. So you just select the two sketches that you've done. Obviously, they have to be closed contour. If they're not, then it's not going to work. And you can do a remove. So that gives you this lovely shape here with a kind of graduated, angled side here. And this is exactly what we need because on the shower rail, on the end, you have this slightly larger bit closer to the wall, and that narrows down to a thinner bit, which obviously you need to cater for to make this a snug fit. But also this is quite useful because if the wall goes on the left, then and this is screwed into the wall, then this is going to hold it in place. It's going to pull it to the wall as well as support it from underneath. So that's the basic shape. And then I did a sketch here. There we go. I did a 3.5 mil diameter hole, and I just tried to put it roughly in the center point of this area. So I did 10 mils from the left and 12 mils down. And then I could have kept that the same and just extruded all the way through, but I looked at the screws I was going to use and I wanted a nice tight snug fit. So actually I drew another circle on the other side, same location of center, so 10 mil from the edge and 12 mil down. But I made this 3 mil rather than 3.5. And then I lofted the two together. Oh, and nothing happened. That's not good. There we go. And I did, again, a loft remove to remove, oh, it's disappeared entirely. There we go. So it's basically a hole. You could just loft remove or extrude remove all the way through, but I quite like this reduction in diameter. That's quite nice. So you could just leave it like that. I didn't want the screw heads to be poking out the end, so I did a little countersink thing here. I just did a chamfer. What was that? I did 1 mil, 3 mil chamfer. So the head of the screw is going to be flush. That means it's not sticking out. It looks a bit better, and hopefully it's less likely to get water ingress and damaged by water. And then you do a mirror, feature mirror. So I think I did that, the loft and the chamfer, to flip it over to the other side. That's quite nice. So if you do, as always, if you do the feature, if you do the mirror, Then if you make a change on one, that automatically gets updated to the other one. And that's basically it. I did put a fillet of 0.5 mils on all the edges. Whether you need to do that or not is probably debatable, but I think it looks quite nice if you do that. And there you go. So, and then you go to your part 1 down here, and you can export that as an STL file. Hopefully it just defaults to STL. Export that, and then whatever 3D printer you have, you can import your STL file and then slice it and then print it out. So yeah, this is I'm really pleased with what I've done. I did one of these for obviously for both sides. I think I changed it slightly, so I did a few different dimensions, bit of trial and error. But yeah, so far it's working really well. It looks quite good. What I did just to finish off, I put a little cap over the head of the screw just to make sure that's protected, because obviously this is going to be in a very moist environment and you don't want the screws going rusty, and it looks quite nice to finish off. So yeah, give this a go. It's a nice little project. It's fairly straightforward to do, and yeah, let me know how you get on and if it works. I will make my STL file available on a link below in the description, so if you do want to just use the one I've created already, then you're very welcome to get access to that. Yeah, enjoy. Happy 3D printing.